Welcome to McKinley Railway. So we've got one last piece of the jigsaw to fill here on the extension. Steve Davis's incredible creation, all the way from the ground up through Hades. We've got Sheffield installed, Wakefield, and then there's this void. You can see here, by the way, the temporary shoe fly that connects Wakefield up. That will get replaced. You might wonder why on earth I'm standing on Hades right now. That's because the finished operating height of Halifax is actually going to be higher than some of our operators can use. So we're going to have to lift the floor in this area. It's just a shame Steve isn't here to come and see it being finished.
Or so you thought.
Fantastic, he's here, let's go.
So welcome back to Model Railway Solutions. We're in the workshops again. I'm James from James's Train Parts, and what are we doing here today? Well, this is Halifax, the next section of the McKinley Railway. Last time you saw us here, we were building Wakefield, and if you've seen the previous videos, you've seen we've now installed that on the McKinley Railway. As I say, this is the next step, and it's the penultimate step. We've got a yard, Halifax B, which is to go with this, but this is the last big build for the scenic area. So what have we got here? We've got all the track laid down. A lot of the electrics are installed. I remember from the video before when we installed Wakefield, a lot of people asked, what have we done and how particularly did we do it? So I'd like to show you some of the things we go through and why we do things the way we do. So as you can see, we've put a lot of cork down, all the track is pinned down and the main structure is built. We've got the canal down at that end and we've got a raised section for the main platforms at the back of the layout here. Just little features. When you're looking in from the front, the station is slightly higher than the yard, gives a feeling of terrain, makes things look a little less flat. You may be able to notice a few things here. There's a red wire tied around the rails there. That's purely there because I've forgotten to solder a joint together, and it's a reminder to me that the red rail needs to be soldered at that point. Nothing stands out better than a piece of red wire. Not sure whether you can see or not, but there's all these pins sticking up through every single point. They're the point motors or the bars. I haven't cut them off yet. I haven't finished testing yet, so until we've done all the testing and everything's happy, I don't want to cut them off now, because trying to change a point motor with a short pin is a real pain to do. But as far as the top goes, everything now is finished. All the track is laid and all the feeders are in. And what I mean by that is every section of rail has got a wire soldered to it. So for example, this section of rail right here has got a red wire and a black wire soldered to the underside of the rail and pushed through the board. I always solder everything before laying the track, so I position the track, line it up, mark the hole, turn the rails upside down, solder to the underside, and then put everything back down again. And I do that so when it's ballasted, you can't see it, but they really are there. Halifax is actually made of three sections. The first section, which is off shot that you can't see, this is the second section, this is the third section, and they're jointed through here. Now we haven't done your traditional baseboard joints. This is not an exhibition layout. Once it's installed in McKinley, it's not going to be coming out again anytime soon. So for now, the boards are just clamped together. We will actually screw them and bolt them together on site, but for the purposes here, this is ideal. The rails are spanning across the joints at the moment, and I'll do the same sort of joint that I did in Wakefield. But for now, what we're going to do is we're going to flip this up onto its side so I can show you what's going on underneath. So here we have Halifax up on its side, and we've clamped it down just to make sure it doesn't fall off. And here's the wiring under midway. It's a bit of a rat's nest, but we do know what's going on here. So as I said earlier on in the video, we had all the track feeds that come through, and these are small red wires or black wires that poke through the board, and you can see there's lots of them coming through all over the place. That's the first thing we start with. Normally it's fairly clean underside. Before I start connecting anything up, I fit all the point motors. These are the tortoise point motors that you can see, these big green blocks. I get them all mounted and installed, and I do a manual check to make sure they're throwing the point in the right place. I then install the other components, such as these little devices. They control the uncouplers, and that's an uncoupler there. And the infrared detectors, I install those as well. I install all the main components just so I get an idea of where everything is and what space I have. The next stage is to hook up the power supplies to the track. Now if you were building a traditional DCC layout, you might want to connect all the reds together and all the blacks and connect it to your command station. This layout is a little bit bigger, as you may have noticed, so we have a lot of different districts and sections. And most, for example, a siding will have its own block, a station will have its own block, so there needs to be a different red wire feeding each individual section. But because I said I'd put a feed wire to every single rail, you may find you end up joining lots of wires together to form one block. And that's what we did. Now you may remember I said that this was in 3 boards. The first board is offset down that way, this is the second, and this one here is the third, there's the joint. The third board is the board that's going to house all the electronics and in a drawer that slides out from underneath. And these are the wires that are going to go to that. So everything from further down the boards needs to work its way back here. So this is the end that I start from. So with track feeds, there's a black and a red coming through there. This is a much lower gauge wire because it's only for the local feeder, but it joins into a much heavier gauge, which is the main DCC bus for that particular section. Now this particular wire, there's a wire that runs out into the tails, which will go into the control panel, and the other wire runs through, hooks up to various other feeds. I have a block in here, which is a connector block, a temporary block, which will show you why we do that in a minute, and then it runs through to other bits further down the layout, and it may not run that much further on. There are maybe districts that are all the way down at this end, there's only down there, and then a red wire runs all the way back through, back into the tail. And we do the same thing with the black. There's less blacks than there are reds because the blacks are common, the reds are the individual sections. Once I've gone through and connected all those up, soldered everything up, I use solder for most joints because it's the most reliable way. I then do some checks, and if I'm happy with that, I move on to the next stage. In particular, this stage was connecting up the point motors. As I said, I'd already mounted them all on, and there's a chock block that you can see there separating the wires. The reason why we do that is if, unfortunately, this motor fails at some point in the future, to replace it, all we have to do is undo the wires, undo the screws holding it in place, take it out, put a new one in, reconnect the wires in the same location, and there it's fixed. You haven't got to chase all the way back through the loom trying to find a joint in the wire. The wire we use for the point motors is actually a alarm cable. It's a 4-core cable, and it makes it a lot easier than running lots of individual wires back and forth. Nice thing about that is as well, on the end of the wires, once again they look a bit of a mess like this, but every single wire has got a code on it, and that refers back to the master plan. The point motors are on the third section, or where the main control panel is going to be. All the wiring won't actually be separated for transit, so these can all be fixed in place, and this is where they're going to stay. But the wires, like this loom here, that you can see running all the way through to the point motors further down, will need to be separated so we can move it over to the McKinley Railway. So what will happen is, this will all be fixed in here permanently, but these wires will be fed back through this hole and be hanging down in a reel here. When I get it back to McKinley, I'll feed the wires back through the holes, back into the loom, and back to the control panel. With all the point motors connected, I then look at other devices such as the infrared detectors, which you can see down here, and there's some more scattered about various places around the layout. These require a power supply and then the wires to tell the computer whether there's a train in the section or not. The power supply will daisy chain around all the various devices, and the wires for those in particular are blue and brown. We again use the alarm cable for running the signal wire back through the loom, back to the control panel. And there's a white wire for every single infrared detector on the board. The other boards that we have, such as this red one here, is for the RFID. Now the nice thing about these is they're Wi-Fi. There's no actual wires, but you do need a power supply. And the white and blue wires, that's the power supply for those. The black wires are just going to the actual devices under the track for picking up the individual wagons. Other devices that we have on here are the KD uncouplers. This is what this red coil here is. It's an electromagnet. And again, this requires power. Power coming into that is blue and black. And then the yellow wires are the individual feeds that go to the individual uncouplers. Now as it stands right now, all this looks quite a mess. But again, I'm still in the process of testing. I have to finish this. I've still got some other things to install. Once that's all done, I will then go through a full regime of testing this. I will make sure that all the points throw properly, everything is wired up in the right polarity. I will test all the infrared sensors. I will test the uncouplers. And at that stage, when I'm happy, I will start fixing these wires up and making it neater and tidier. I've had to start on this a little bit. You can see some of these strappings holding it in place. I do that as I go, mainly so the wires aren't pulling on the devices and putting any strain on them, but I will do a lot more of this once we're done to make it nice and neat and nice and tidy. The last thing you want is wires hanging down, catching the trains that will be running underneath. So the stuff that isn't on here at the moment are the wires for the signals. Again, this will be alarm cable. I also don't have the lighting on the underside. We put on LED strip lighting so it illuminates the tracks on the storage in Hades down below. I'll be getting that in over the next week or so, doing some more testing, and at that point I can then tidy everything up as I said before. There's a few other things that you might have spotted in here. You might be wondering what they are. On a lot of the wires you can see this black goo that's on here. And what this is liquid electrical tape. The reason being is I solder all my connections up for reliability, but then you've got exposed wires. And trying to wrap insulation tape around them is a real pain, but the liquid electrical tape on a brush, you can just paint it on and everything's covered. Chances are things aren't going to be able to short across there because everything's fixed, but you never know. A few other things that you can see on here, these wires that are poking through here. These wires are attached to the underside of the point. In fact, this is a double slip that's in here. But every single point has been made DCC friendly, or almost super DCC friendly. So here's a Pico point that hasn't been modified. You've got the frog wire that you're used to. But what we also do is we solder on feed wires to the areas where the timber's been removed. We bridge between the stock rail and the blade, and if I turn it round, there's the blade on the inside and there's the stock rail. And the reason why we do that is that every piece of rail is then fed by a wire. You're not relying on contact between the stock rail and the blade or the little hinge that's up here. Those wires hang down through the layout, and these are what you can see here. They don't need to be connected to anything, but you need somewhere there to go, and they need to be able to move very slightly as the point changes. So all through the layout you'll see these little wires poking through, and I've used purple wires just so they stand out. And I've also covered the end of them with the liquid electrical tape so that there's no danger of them touching each other and shorting out. Looking at the boards from the other side at the joints, you can see we've got a tag strip here, and this is used for local connections. The big wires that are only connected to the previous boards are all coming through solidly, but sometimes we have to bridge wires from one board to the other. So I do that using a tag strip. All these wires that are loose on this side will be permanent. They're part of this board, and they'll all be fixed in and made look nice on this side. But the ones the other side, they're currently soldered and they're all labelled. You can see the labels there. But what I will do before installation is I'll unsolder these, pull them back through the holes, temporarily tie them up, and then when we get to the McKinley Railway I can push them all through, and because they're all labelled I can see where they go. I will shorten them, resolder them, tidy them up, and they will be the last of the connections made, ready to use. So to finish this off, we've got another day or two of wiring to do, day or so of tidying it up, and then we're going to run some trains on it, make sure everything's okay, make sure everything's ready for the McKinley Railway. Then it's a matter of tidying up bits and pieces on the top, and the very last thing I'll do before we take it round is I'll spray the track to make it look all grimy and mucky, and then we can deliver it.
So you've seen the excellent progress that James is making on the layout. Things are apace here as well. I just wanted to show you where we're at with a few of these things. The control panels, Pete is starting. This is the main control panel for Halifax Copley Street. It's all been laid out, designed, and we're building all the DTM30 panelling and infrastructure behind that. So Ivana has painted that up and it looks fantastic. We also have, to follow on from that, is the gasworks yard. This one hasn't been painted, this has just come straight from Hay Create, and you can see the translucent areas that we'll fill in with paintwork to give them the distinctive colours that mean different things in different areas of the yard. And so you remember the rat's nest we had with all the ribbon cable wiring going to all the LEDs and switches on Sheffield 1. Well, we did something about that. Sheffield 2 is a lot better. Wakefield, that's installed upstairs, is finished and working. But I have an example of the changes we've made with the small panel here, which is going into Wakefield. It's just going through testing here. That's the fascia. It follows the standard interface that you've seen. And if I now turn around on the inside, turn it round here, you can see that it's fundamentally quite different. The strategic thinking we went through was, how do we help with the loom design? The first inspiration came from Ian about using rainbow ribbon cabling. It allows you to identify the individual ribbon or wire numbers as you're going through, so it's much easier to find the green or the yellow because you're looking for a specific colour rather than them all being grey. And the second thing is that we designed it in layers so that the DTM30 board has 3 of these ribbon cable connectors. And so the bottom one here and here, they come out and they service the bottom switches and the bottom LEDs. The next layer up comes out and services the middle band, and the top layer here comes out and services the top band of switches and LEDs. We also found these delightful cable clips that are used to hold things in place, and that's transformed our ability to test and repair, probably the wrong word, but you know what I mean, to make sure these things are coming out. We've tested them. It's a lot easier to get them into production and get them finished, and Pete's enjoying doing this a lot more than struggling with thousands of little grey wires. So if you watched the design video with Clive and Gordon, you'll remember that Clive designed a gasworks for us. When we went into researching what are the outgoings from a gasworks, it was a whole stack of chemicals. You've got obviously coal going in, coke coming out, and tons of different kinds of chemicals, from tar, from benzene, ammoniacal liquors, I never even knew that existed before, and other things as well. And so we had to invest in tons and tons of tank wagons of all different varieties and colours and brands, some for chemicals, some for benzene, some for bitumen. And then we also didn't have enough insil vans for all the chocolates coming out of McKinley's chocolates and toffee factory, so more were purchased there, as well as more tanks. So with this little family of wagons, which are all now being weighted, they're being numbered into their sets, they're being resisted, they are being then weathered, and then we've got to go through the operational proof running of them all, then we should be ready to go at the same time as James delivers Halifax. The software has been updated. However, as we've been going through all these wagons, it's brought up a perennial problem. Let me show you. We've been plagued with all the different coupling heights that have existed over time. And all the manufacturers have gone over to NEM sockets in recent years, and in theory, that solves everything. But what we found is this. None of them follow the standard, pretty much. This is both Bachmann and Hornby. They have different coupling heights. Come and have a look in detail. So this is going to be the subject of probably a dedicated video on couplings. This is a relatively new Hornby model. This is a relatively new Bachmann model. This is an older Bachmann model. They've all got NEM pockets. This is an NEM coupling gauge. It's a pocket height gauge. We've checked it. It complies with the standard. And the British 00 Gauge Association adopted this as their standard in 2007. None of these guys follow it. And so it gives us a real challenge with these couplings, with KDs and anything else. And we'll make a specific video about how we get around that and the things we've done when the time comes. But the problem continues to bite us. So there we have it. We're making great progress on Halifax, and I can't wait to show you the installed article and trains running on it. Thanks for watching.